Hello together, my name is Thomas Schmidt. I'm the Deputy Head of the Sales Department of FUG Electronic GmbH. I want to tell you today something about the common features of FUG power supplies. I have here brought with me two FUG power supplies of the HCP series, and you already see they are a little bit different. This is because they have different optional features. I will tell you now something about the common features, and after this something about the optional features of the power supplies. The first, which is common for each FUG power supply, is the main switch. You find the main switch always on the left side of the front plate of each power supply, near the bottom. If you switch on the main switch and have connected the power supply to the mains, after a short message you see the power supply is on now, and already the displays are glowing and some LEDs are start to glow. For each FUG power supply, also common is that they have two potentiometers for adjusting voltage and current. You see here two potentiometers. This one has three. This is an optional feature which I talk about later. The potentiometers are 10-turn precision potentiometers. With a precision dial you have 10 turns to adjust the voltage, for example here. I tell about this button a little bit later. And you can, when you did the 10 turns, you will see this is the power supply which can deliver up to 20 kilovolt. And you see now I have adjusted 20.000 kilovolt. The potentiometer dial has 100 divisions for one turn and has 10 turns. You see in this little window here the number of the turn which you have chosen. This is now the tenth of the turn. And so you have approximately 1000 different possibilities to adjust such a potentiometer. The same you can do with the current. All FUG power supplies have voltage and current adjustment possibility. And the selection between constant voltage and constant current mode goes automatically. I can talk about this later a little bit. You see now that the display here is blinking. This is because I have pressed this button before. This button is the set value button. If I press it again, the display is now not blinking anymore, and it shows still 0 volt and 0 milliamps. So voltage and current is still 0. So the power supply has now adjusted some current and some voltage, but it still delivers no voltage and no current at the output. This is because the output is not released yet. This button is a little bit tricky. If you push it only short time, you see for some seconds the set values, and then it switches over to the actual values again. Same as here also. See, I have adjusted 1604 volt, and now it shows the actual value again 0. If you push the button for a longer time, it will not switch back anymore automatically, and it shows now the set value for a longer time. So you can, for adjusting, for your comfort, for adjusting the set values, you can press this button for a longer time and see now the blinking displays always show the set value. If you will want to see the actual value again, you can push the button again and you see it's now the actual value. So now you want to have, of course, some output voltage from the power supply. For this, you must release the output. For a power supply which is not operated via any of the interfaces, also, which is, we call it in the local mode, the power supply, you must press the button on/off. If you press this button, the output will go on, and when you have adjusted some current and some voltage, then you see that now the actual voltage goes to the previously adjusted value, 1604 volt, and the actual value is also 1604 volt. You see this, that the power supply is working now and delivers this voltage really at the output. You see this at this LED. The LED on is glowing now and shows you that the output is on. If you have looked right, you saw that when I switched this button in the first time, the actual value did stay at 0 for a short time. This was because I did not adjust any current in the first time. You must, for every FUG power supply, you must adjust at least a little bit current. You see here, I have now adjusted 0.17 milliamps. This is enough to charge the output. If the current still stays on 0, it may happen that the voltage not goes up. This is some error picture which comes sometimes to us, and before you call FUG service, please check whether you have selected also a current and not only a voltage. Now some words about the displays of the power supplies. You see here the displays of the standard power supply. The displays are 4.5 digit displays. If I adjust the full voltage, so for this power supply, this is 6.5 kilovolt. I have now 6.5 kilovolt adjusted with this power supply. Just one moment. So, and it's shown on the display. You see 4 digits are shown. The 6, then the point, decimal point, and then 3 further digits. Both of the power supplies which we see here have a 4.5 digit display for voltage and a 4.5 digit display for the current. You see here, let's adjust the 6500 volt. This is the maximum voltage of this power supply. Here I have also adjusted 6500 volt, 6501 in this case, because this has not the fine potentiometer. But I can adjust more. This power supply can deliver up to 20 kilovolt. And you see here now, it appears 1 digit more. When the voltage comes to 10 kilowatt, 1 digit more does appear. And I can put now 20 kilovolt. So, now nearly 20 kilovolt. And you see this digit, the first digit, is the so-called half digit. It can show a 0, a 1 or a 2. It cannot show a 3. So for the 20 kilovolt power supply, we have 1 digit more. We have 5 digits here, and we have only 4 digits which are shown here. This is the meaning of the 4.5 digit display. The same is for the current. I can't show it for the current now because we have no load switched to the power supply. So if you buy a power supply with output voltage or output current where the maximum begins with 1 or 2, so you will have a higher resolution of the displays. If the resolution of the displays is still not enough, we can offer also 5.5 digit displays. For 5.5 digit displays you will have, the display will be a little bit bigger than here, and you will have 1 digit more even so you will have 6 digits for a voltage which begins with a 2 or a 1, and you will have 5 digits for all other power supplies. So this is one of the optional features. We propose to combine the feature of the 5.5 digit display always with the feature of higher regulation stability and lower ripple of the power supply. Because otherwise, if you have a power supply with normal regulation stability and you will show 6 digits here, so the last digit is a very low voltage which it represents, and if the regulation stability is 10 power minus 4 and the last digit shows 10 power minus 5, then the last digit may be not stand stable. You see when I switch the button on off, you see also that in the beginning this LED was on. CC means constant current, so the power supply was in constant current mode and the current was set to 0. If I set it again to 0, it goes in constant current mode, the LED goes on and the voltage now goes down slowly because the output discharges now. The power supply now tries to hold the current constant on 0 and not the voltage. Now, when I give some current, the power supply goes in constant voltage mode again. The CV LED is on. If the power supply is operating normally, always one of these two LEDs should be on. If they both off, this happens when the output is not released. If I push this button and release the button, then the output is now not released anymore and both LEDs go off. And the same may happen when something else happens, when the power supply shows an error. So both LEDs will be off. This is always a sign that something is not switched on or something unusual did happen with the power supply. Now I switch it on again and the CV LED goes on and it goes to the adjusted value again. These are nearly already all features on the front plate. About the back plate I can tell you later on something, which are common for every FEG power supply. One thing I did not talk about before is this potentiometer V limit. If I turn it to the left, a red LED will go on and you see the voltage goes down now. So you can adjust by this potentiometer, you can adjust a maximum voltage which can be adjusted with this power supply. I will try to adjust now 1500 volt. This potentiometer is not as accurate as the 10-turn potentiometers. It is less accurate, but it allows, if you want to go with your voltage not higher than 1500 volt, you put it to 1486 for example, and now you can adjust the 10-turn potentiometer as you want, as long as the red LED is on, the voltage will not increase anymore. If you go down, then the red LED goes off, and now you can adjust the voltage. 1067 volt, 1128. But when you reach the 1485, the red LED goes on and you cannot adjust anymore. You can turn the potentiometer, the voltage will not go higher. So if you have some reasons that your load will break when the voltage goes higher than 1500 volt, for example, you can use the adjustment of this potentiometer. This potentiometer cannot be overridden by any adjustment. Also, if the power supply is equipped with interface, analog or digital interface, also if the interface sends data that you want to adjust a higher voltage than is adjusted on this potentiometer, it will not work. The red LED will go on and it will not deliver this higher voltage. So this can be used for some safety reasons, but please not for personal safety. For personal safety you must do special measurements. This potentiometer may also be a reason of some errors which happen when it is adjusted wrongly. Then often customers think that the power supply doesn't work anymore correctly, and they tell us, okay, my power supply delivers now only 1500 volt and not anymore. And then please, if you have such an effect, please check this potentiometer and turn it to the right, completely to the right, and then the power supply will deliver any voltage which you can adjust and which it can deliver. This was something about the common features of the FUG power supplies, and now I will tell you something more about some of the optional features of FUG power supplies. These are features which you can order if you need them. We have a lot of options, and here are represented 3 of them. One of the most common features which is ordered very often is the polarity reversal switch. This is a button on the front plate, and if you press this button, this is an arresting button. So it arrests in the pushed or in the released position. Now I release this button and it comes out a little bit. Here on this picture you see if the button is out, the polarity will be negative. You saw that the voltage goes down slowly. This is because the output of the power supply needs some time to discharge. We have not switched any load this time to the output, so the time for discharging the output is maximum. If you have a load on the output, it will go faster. After the output is discharged and the voltage, I do it again, I go now to positive polarity again. You see if the voltage goes down, and if it reaches approximately 50 volt, then you hear some noise from inside the power supply. There is some components internal are moving mechanically, and then the polarity changes, and you see on the LED that it is now positive again. Before it was negative, and the voltage is the same which you have adjusted before. So the same is for this power supply. Switch it on, and you have 20 kilovolt on the output of this power supply. Now negative polarity. I switch the button. Now the voltage goes down. And now it has 20 kilowatt positive polarity. The polarity switch which we use for this small power supplies is not for a use very often. So you should not use it within, let's say, 100 times a day or so. It is for use 1, 3, 10 times a day though. This is the polarity switch can operate approximately some 10,000 moves over the lifetime of the power supply. So if you have an application where you have to change the polarity every minute or every 10 minutes or so, please tell us and we will search for you a special solution. But for changing the polarity one time a day, for example, if you have experiments, one with positive polarity, one with negative polarity, and you have to change for the polarity for the next experiment, it's a very good method to change the polarity, because you must not open the power supply, you must not change any parts, you can switch it from the front plate, and you can also, when the power supply is equipped with an interface, you can also give an external command and the power supply will change the polarity also on external command. A further feature which you can order for nearly all FUG power supplies is the option of the coarse and fine potentiometer. They are available for voltage adjustment as well as for current adjustment and also for both adjustments. You see here the power supply on top here is equipped with a coarse and a fine potentiometer. The function of those two potentiometers are as following. If I try with the coarse potentiometer here now to adjust 1500 volts exactly. So you see it is very hard. It is very hard. I can adjust it, but it is very hard. If I make a little move on this potentiometer, I have already changed the output voltage for some volts. And for this is this fine potentiometer, which has a window of 1% of the full range of the voltage. And now I can adjust easily 1500 volts if I turn the fine potentiometer. The coarse potentiometer covers a range of 99% of the full range of the voltage of the power supply. So I can here adjust nearly the 6500 volts, but not completely. And to adjust it complete, I must turn also the fine potentiometer full, and then I have here adjusted the full voltage. So both potentiometers are equipped also with a lever where you can fix the position of the potentiometer. So let's say I will now adjust 5790 volt. So I must do a little bit less. 790 I have it. So now with the fine potentiometer I can go down to the 790. And now I want that nobody can move this potentiometer anymore by accident. So I put this lever to the right. I did already move it a little bit. And now the potentiometers are arrested and they cannot be moved anymore. So the voltage is now very fixed and very stable, and nobody can change the Z value of this voltage. Of course, what I showed you now is already the actual value, because I have switched the output on. You can do this, of course, also with the Z value. When the displays are blinking, you see the Z value, and it is exactly the same. For some power supplies, they have this fine potentiometer also for current, so you can adjust the current also very exactly. In this case, you see that the actual value of the current is of course 0, because no load is switched to the output. So these are the coarse fine potentiometers. Please think about if you need a FUG power supply and want to have the possibility to adjust manually voltage or current or both very accurately, very exactly, then you possibly need to order this option fine potentiometer. If you want to adjust the voltage and current by remote options, by the interface, analog or digital interface, you don't need this fine potentiometer because the interfaces have a very high resolution of up to some 20 bits, and you can adjust the voltage and the current by the interface very accurate, also without having this fine potentiometer. A further feature which we have on the power supply on the bottom is the so-called interlock feature. You see that this power supply don't have this on-off button which the power supply on top has, and which is the usual way to switch the output on and off. For this power supply has three buttons here on the right side, which is one is on, one is off, and one is reset. So the on and off is nearly the same function than for the power supply above. You have here on and off and on, and here you have two buttons for this. The on button goes on, you push the off button, it goes off, and the voltage runs down now. What is this reset button? This power supply has a special connector on the rear side. I think I put the power supply now with the rear side to the front to show you this connector. So, you see here this connector with 3 pins, and pin 1 and 3 is now connected by a wire simply. If you order the power supply with the interlock option, you will get a mating connector for this socket, and you can make a cable there. You can connect this cable, for example, to door switches, to other safety features, but also material safety, not personal safety, please. And then you can switch off the power supply. I will now show you the front again, and then I will disconnect this wire. Now I disconnect this wire. That was already disconnected. Okay, I connect it again. Just a moment. Connect it again. Voltage goes up to 20 kilovolt. I disconnect this wire. So maybe a door switch has opened now. The wire is disconnected. The voltage switch is off, and the power supply switch is off, and the voltage goes down. But you see, it goes down slowly. So for safety reasons, for personal safety, be careful to use this, because it takes some time before the voltage goes down. But it has switched off now, and it's not possible to switch it on again. If you push the button on, off, it goes not on, and it's also not possible to switch it on via interface or other. Only after the interlock loop, so the connection between these two pins of this socket, has been restored. I push the bridge now. Then you can push the reset button, and then you can push the on button, and the power supply will go on again. If the interlock is off, I make it again. I disconnect the interlock, you push the reset button, nothing happens. On button, nothing happens. But the bridge installed, and you can switch on. So now some words about the real side of the power supplies. Usually every power supply has a mains input connector. You see here the mains input connector. Then you have an output connector, which is in this case a high voltage connector. There may be other connectors for other types of power supplies. You have the 20 kilovolt output connector and the 6.8 kilovolt output connector. Then you have an earthing stud, which is connected with the case of the power supply. And you have a 0-volt output. This is the output where the current should come back to the power supply. Now for all FET, or for the most of the FET power supplies, the 0-volt output is connected with the earthing stud internally by a bridge. This bridge must be not removed without our permission. If there is a reason to remove this bridge, maybe it's possible, and you can ask us and we can tell you how to remove this bridge and how you can work with the power supply with 0-volt and power earth disconnected. Normally when we deliver the power supply, the bridge is installed and 0-volt is connected to the power ground and so to the case of the power supply, to all touchable screws and so on, and also to the screen of the output connector if there is a high voltage output connector, and to the cable. So you can use, in this usual configuration, you can use the screen of your high voltage cable to let flow the current back to the power supply. This is already everything which is common for each FET power supply. Optional features, we see here analog programming analog. It's covered by a cover in this case, because these two power supplies don't have the analog programming. You see the slot for the digital programming. It's covered here because this power supply don't have a digital programming. This power supply has an Ethernet interface. So a LAN Ethernet interface. So you can switch your LAN cable to this interface, but there may be also installed an IEEE 488 interface, an RS232 Profibus interface, and some other interface which are described in our datasheets. And what I did show you already is the interlock connector for this power supply. So this is some words about the real side of the power supply. Thank you for your patience and for watching our video, and I hope you did enjoy it, and I hope you understand now better the operation of the FET power supplies. Thank you.